of double stars, when we examine the motion of distant galaxies, we find that all over the universe, Kepler's laws are obeyed. Many years later, Kepler came upon his third and last law of planetary motion, a law which relates the motion of the various planets to each other, which lays out correctly the clockwork of the solar system. He discovered a simple mathematical relationship between the size of a planet's orbit and the average speed at which it travels around the sun. This confirmed his long-held belief that there must be a force in the sun that drives the planets, a force stronger for the inner fast-moving planets and weaker for the outer slow-moving planets. Isaac Newton later identified that force as gravity, answering at last the fundamental question, what makes the planets go? Kepler's third, or harmonic law, states that the squares of the periods of the planets, the time for them to make one orbit, are proportional to the cubes, the third power, of their average distances from the sun. So the further away a planet is from the sun, the slower it moves, but according to a precise mathematical law. Kepler was the first person in the history of the human species to understand correctly and quantitatively how the planets move, how the solar system works. The man who sought harmony in the cosmos was fated to live at a time of exceptional discord on Earth. Exactly 8 days after Kepler's discovery of his third law, there occurred in Prague an incident that unleashed the devastating 30 Years' War. The war's convulsions shattered the lives of millions of people. Kepler lost his wife and young son to an epidemic spread by the soldiery. His royal patron was deposed, and he was excommunicated from the Lutheran Church for his uncompromising independence on questions of belief. He was a refugee once again. The conflict, portrayed on both sides as a holy war, was more an exploitation of religious bigotry by those hungry for land and power. This war introduced organized pillage to keep armies in the field. The brutalized population of Europe stood by helpless as their plowshares and pruning hooks were literally beaten into swords and spears. Rumor and paranoia swept through the countryside, enveloping especially the powerless. Among the many scapegoats chosen were elderly women living alone who were charged with witchcraft. Kepler's mother was taken away in the middle of the night in a laundry chest. It took Kepler 6 years of unremitting effort to save her life. In Kepler's little hometown, about 3 women were arrested, tortured, and killed as witches every year between 1615 and 1629. And Katerina Kepler was a cantankerous old woman. She engaged in disputes which annoyed the local nobility, and she sold drugs. Poor Kepler thought that he himself had contributed inadvertently to his mother's arrest. It came about because he had written one of the first works of science fiction. It was intended to explain and popularize science and was called The Somnium, The Dream. He imagined a journey to the moon with the space travelers standing on the lunar surface, looking up to see, rotating slowly above them, the lovely planet Earth. Part of the basis for the charge of witchcraft was that, in his dream, Kepler used his mother's spells to leave the Earth. But he really believed that one day human beings would launch celestial ships with sails adapted to the breezes of heaven, filled with explorers who, he said, would not fear the vastness of space. He speculated on the mountains, valleys, craters, climate, and possible inhabitants of the moon. Before Kepler, astronomy had little connection with physical reality. But with Kepler came the idea that a physical force moves the planets in their orbits. He was the first to combine a bold imagination with precise measurements to step out into the cosmos. It changed everything. This fusion of facts with dreams opened the way to the stars. As a boy, Kepler had been captured by a vision of cosmic splendor, a harmony of the worlds, which he sought so tirelessly all his life. Harmony in this world eluded him. His three laws of planetary motion represent, we now know, a real harmony of the worlds. But to Kepler, they were only incidental to his quest for a cosmic system based on the perfect solids, a system which, it turns out, existed only in his mind. Yet, from his work, we have found that scientific laws pervade all of nature, that the same rules apply on Earth as in the skies, that we can find a resonance, a harmony between the way we think and the way the world works. When he found that his long-cherished beliefs did not agree with the most precise observations, he accepted the uncomfortable facts. He preferred the hard truth to his dearest illusions. That is the heart of science.